Okay, this is the third video for the 5354 concept review. I was going to have you guys try this on your own, but then I thought maybe I shouldn't. So these are all fundamental theorem of calculus. So remember, fundamental theorem of calculus says if you take the derivative of an antiderivative, derivative of an antiderivative will just give you the function out. So in all these cases, they're defining this capital F of x as the integral, and I wrote under here antiderivative, it got erased. So this is an antiderivative, and they're asking us to take the derivative of it. So when your antiderivative here has a number on the bottom, a constant, and a plain old x on the top, then it's straight up fundamental theorem. If I take the derivative of this, what I get out is the function evaluated at x squared. So I'm putting the x in place of the t. So those work out nice. They ask you to take the derivative of an antiderivative. If you have a number on the bottom and a plain old x on the top, you're good to go. What comes out, or what you're after you evaluate it, you just get the function with the x substituted in. Now, if you look at this one, I have a number on the top, but I do not have a plain old x on the top. I have a 2x on the top. So think of these as chain rule. So what I'm doing is the derivative of the inside, so I'm going to plug this 2x in here. So I need to take the derivative of the inside, which would be 2. The derivative of the outside will be the function. I'm still getting the function out, but what I'm evaluating it at is, instead of plain old x, I'm evaluating it with a 2x. So it's just like chain rule. Derivative of the inside is the 2x. Think, because I'm plugging the 2x in here. So derivative of the inside is 2 times derivative of the outside with the inside evaluated at that. So think I'm plugging the 2x in there. So this would be 2 times the square root of 4x squared plus 1. Okay, so whenever you don't have a plain old x up here, whatever you have up there, you're going to substitute into the function. That's going to be like your derivative of the outside. Derivative of the inside is derivative of this function up here. Now this one, really, still fundamental theorem, because this is an antiderivative. They're asking me to take the derivative, but I don't have a number down here, and I have a function up here. So I need to do a lot of changes to this. So you might want to pause this video and copy this. What I'm doing here is I'm using those properties of antiderivatives that are in section 5.3. And what I'm doing is I want to split this, and I need to add a constant in there, because fundamental theorem requires I have a number or a constant on the bottom. You can put whatever number you want in there. 0 is just a nice one to choose. And then I'm linking two derivatives together. So if you just look at these two, not derivatives, antiderivatives, if you look at these two integrals, I'm starting from x, I'm going to 0, and then I'm going from 0 to 2x. So this is that additive property that's in 5.3. And if you can think about it, if I'm taking the area from 0 to x, and I'm adding it to this area from 0 to 2x, that's going to be the same as the area from x to 2x. The analogy I like to use for this one is, if I leave my house and I stop at the store, and then I go from the store to school, I've still gone from my house to school. So when you combine these two integrals, you have to make sure the upper bound of this one matches the lower bound of this one. So these are equivalent. I'm going from x to 2x, I'm going from x to 2x. This one I can do fundamental theorem on right now, because I have a number and a function at the top. This one, I have an issue. I need the number to be at the bottom, like this. So another property says if I want to switch the upper and lower bounds, I can do that. I just do a negative out front. So I'm going to make this 0 to x of 1 over t dt. And this I'm going to keep the same. So this is my new capital F of x. Remember, I'm taking the derivative of this now. Now I can do fundamental theorem on this. Fundamental theorem, so I'm going to say f prime of x, keep that negative. This is straight up fundamental theorem. So this is just going to be substitute the x into the function. This is close, but I have a function up here. So derivative of the derivative of the inside, if you want to think about it that way, I'm going to substitute 2x in here, times the derivative of the inside, which would be the derivative of 2x, which would be 2. So that is that. Now, if you simplify this, I'm going to have negative 1 over x plus 2 divided by 2 is 1, so this is 1 over x. So this is going to equal 0. This is close to fundamental theorem, but I have a function up there. So I'm going to substitute the function in here, and I'm going to get sine of square root of x squared times the derivative of the square root of x, which is 1 over 2 times the square root of x. And then you could simplify this, right? This is, if I square a square root, I'm running out of room here, I'm just going to have sine of x, and that is going to be on the top over 2 times the square root of x. So that's the answer for 4. This is the answer for 3. This one, this is the same. I think I'm going to let you maybe try this one. Remember, I have a function up here, so I need to multiply by the derivative of this. I'm going to plug this in for t, and then I'm going to multiply by the derivative of this. To take the derivative of this, I would probably think of this as x to the negative 1, because it's the same. And this one is not f of x anymore. I don't think. No, so this, well, I guess it is. They didn't write the equals f of x, but I still think they want you to do it that way. We'll do this one. So I'm taking, oh, I see, they have it written a little different. This one also, they have the derivative of the integral, so that's why they didn't call it capital F of x, but you're still doing the same thing, derivative of an antiderivative. This is derivative of an antiderivative, so I'm still doing the same thing. I'm going to get the function out, so this is what I will have, x squared minus 1, but this one they gave me upper and lower bounds, so I'm evaluating that from 1 to 4. So that's going to be square